Hi, this is Brian from Abstract Instruments. In this video, I'm going to go over the features of the Avalon analog bassline. Okay, so for the analog voice, we have the 8 original rotary controls of the 303 bassline. There's tempo and volume, the tune control, filter cutoff and resonance, the envelope mod control, which controls the depth of the filter envelope modulation, the envelope decay control for the filter envelope, and the accent amount control. Now for the additional controls, first there is a sub-oscillator with 3 waveforms, saw, triangle, and square. They can be -1 or -2 octaves. The octave is determined by a switch on the rear of the unit, behind the sub-level control. When -2 octaves is selected, the LED on the top panel lights up. You can turn the main oscillator off by having the slide switch in the center position. This is very useful if you just want to play the sub-oscillator, or an external source plugged into the external input jack. For filter modulation, we have filter tracking. The filter tracking scheme is nonlinear, it's more exponential. When we did implement a linear filter tracking scheme, a lot of the modulation happened at the higher octaves. It made notes very bright, and not much happened down at the low octaves, where you would like it to. With the exponential scheme, the tracking is much more musical. So the envelope decay control controls the decay time on notes that are not accented. So on a normal 303, when a step has an accent programmed, the filter envelope decay time becomes the shortest setting, which in the case of the 303 happens to be about 200 milliseconds. So there is no variable decay. So on the Avalon bassline, we've implemented an independent decay time for accented notes. So you have the normal envelope decay control, which varies the decay time of the filter envelope between a few hundred milliseconds and about 3 seconds. And you have the accent decay control, which does the same for accented notes. Next is the VCA decay control. On the TB303, the VCA decay time of the simple decay envelope is fixed at about 3 seconds. On the Avalon, the decay time can be anywhere from the normal 3 seconds of the 303 all the way down to off. So at the full counterclockwise position, the VCA decay envelope is fully off and has no effect on the VCA. Next, we have the utility envelope. It's an attack decay envelope, and the trigger source is saved with each pattern. The trigger source can be all steps that have a note programmed on them. It can be all steps that have an accent programmed, all steps that do not have an accent programmed, or all steps that have a slide programmed. The modulation destinations are the filter and the VCA. Each has its own independent control, and the modulation is bipolar. In the case of VCA modulation, because of the way the original 303 is designed to be run off a single supply or batteries, when the utility envelope to VCA depth control is turned counterclockwise to give negative modulation, there is a progressively increasing voltage applied to the VCA, to the point where, at the full negative modulation setting, or full counterclockwise on the control, the VCA can be held open. So if you envision that case, the VCA starts open, and the negative envelope closes the VCA as the envelope is triggered and the VCA is modulated. Now, if you're not triggering the envelope and you simply turn the VCA depth control fully counterclockwise, you're basically in drone mode, where you can play the synth and leave the VCA open. Now, with all these modulation sources for the filter and VCA, you can imagine things can get pretty complex pretty quick. So the modulation sources for the VCA can be the normal VCA envelope, the copy of the filter envelope that is sent to the VCA on accented notes, as well as the modulation from the utility envelope. And the same goes for the filter. You have the normal filter envelope, the modulation from the utility envelope, and you have the burst or slewed copy of the filter envelope that is sent to the filter control input on accented notes as well. On the rear panel, we have the various I/O and a few switches that relate to the analog voice. So here we have the power input, the power switch, the main output and headphone output. Next to that we have the various 3.5mm jacks. Starting here we have the CV and gate inputs and outputs. This is the accent sweep output, which is an amplified and normalized copy of the accent burst that is generated from the filter envelope on accented notes. This is the filter CV input, and the next 4 jacks are the audio I/O. There's a saw and square output. They are plus minus 5 volts. Next, there is the external filter input, followed by the filter and VCA output. Next is the USB jack. The unit can be controlled or played via USB MIDI. There's the MIDI I/O connectors here, and the DIN-Sync I/O connectors on the end here. Now for the 3 switches. The first switch here is the octave range switch for the sub-oscillator, as described earlier. So when the switch is pushed in, an LED lights up on the top panel to indicate you are in -2 octave mode. The next switch is the filter B switch. So this is the switch that actually selects between the internal 303 filter and the filter plug-in cart. The last switch here is labeled FR on the top panel, and that stands for frequency response. The original 303 baseline goes down to about 90 Hz. So when this switch is pushed in, the synth goes down to approximately 30 Hz, or full range. The cartridge slot takes cartridges from the synth cartridge system, which in the case of the Avalon baseline are filter plug-in carts. The form factor may look familiar, as it's based off of the Game Boy cartridge system, for which the international patents have recently expired. So what you can see here is a first off tool housing, which simply houses the small PCB assemblies. You can see here this part has a cutaway on top, so we can see the components and demonstrate the system. The production cartridge shells fully enclose the filter assemblies. So now we're going to go over the functions of the sequencer. So in pattern write mode, you can do step entry, just like the 303, where you enter your pitch and time data separately. You can also do everything real time, which is what I'm going to do here. So we go into pitch mode and enter a bunch of notes. Then we go into time mode and enter some time data. You can see as we enter the time data, you can see the active step on the LEDs. Of course, you can go back into pitch mode and step through and edit the attributes of the notes, up, down, accent, slide, just like the 303, except of course you can do it real time. Now, with the addition of the step LED switches, there is a massive improvement to the editing capabilities. So you can go back and forth between the 303 programming modes and the new programming modes. So what we'll do here is take this pattern and go ahead and start to modify it. Here, I can use the step LED switches to enter pitch and time data directly. You can set note lengths simply by pressing the first step of the note and then pressing the last step of the note. Here I'm showing the utility envelope and the various trigger modes. The trigger mode is saved with each of the 448 patterns. So now it's being triggered by all notes. It can also be triggered by all accented steps, all non-accented steps, or all steps that have a slide programmed. You can see it being triggered by accents here. Here, we're back to triggering on all notes. And here it's being triggered by slides, where I've programmed a slide on step 15. To demonstrate the utility envelope, I had turned off all the VCA modulation sources except for the utility envelope itself. So here I'm going to bring back in the VCA decay envelope again, and the contribution from the accent as I increase the accent amount. Here, I'm just messing around with the envelope settings. And here, I'm just messing around and doing some real-time editing. Of course, you can do things like play patterns in reverse, randomize them, and rotate them. Here is reverse. And here is rotating backwards and forwards. Here we have shuffle. There are up to 7 amounts depending on the time signature of the pattern. You can also skip steps. You can see here I swipe the first 3 steps, so our 16-step pattern becomes a 13-step pattern. And then I'll randomly add and remove some steps. There is an arpeggiator. You can play it in real time and revert back to the pattern on the downbeat. Or if you like the arpeggio, or a portion of it, you can record it real time directly into the pattern by pressing the live entry button. Each pattern can be up to 64 steps long. They are divided into 4 sections of 16. You can see here I'm selecting the 4 sections. To add a section to a pattern, you simply select the section and then select the last step. You can see here we now have a 32-step pattern divided into 2 sections of 16. You can see that the current section that you have selected shows as the chase LED gets to that part of the pattern. And you simply select each section to edit that section of the pattern. Of course, you can also transpose patterns and arpeggios. Here we have a pattern with a lot of slides in a wide pitch range. So there are 4 slide times, and the slide time selected is saved with each pattern. The slide times are approximately 30 milliseconds, 100 milliseconds, which is the slide time of the original 303, 300 milliseconds, and approximately 1.5 seconds. So here I'm going to switch between the different slide times. Thanks for watching. The next introduction video is going to go into the design philosophy of the Avalon bassline and some of the technical details.